Imagine a $500 million warship standing defiant against walls of water, towering like moving mountains. It's not science fiction. It's the U.S. Navy's Littoral Combat Ship, a vessel designed to fight and survive where others falter. In the open ocean, where monstrous waves can swallow smaller vessels whole, this ship remains fully operational. Its secret lies in a radical marriage of naval engineering and cutting-edge technology, built to tame the ocean's fury. The Independence-class variant is instantly recognizable. Instead of a traditional hull, it sports a trimaran configuration, a sleek central body flanked by two narrow outriggers. This isn't just for aesthetics. The wide beam gives the ship extraordinary stability in rough seas, reducing rolling to a minimum. Meanwhile, the slender center hull slices through waves like a blade, maintaining speed and stability even when the sea becomes violent. The Freedom-class variant takes a different but equally ingenious approach. Its semi-planing monohull design allows it to glide over waves rather than slam into them, softening impacts that would rattle conventional warships. The bow is flared and shaped to push water outward, keeping the decks dry even when the ocean tries to climb aboard. Beneath the surface, propulsion plays a decisive role. Unlike older ships with propellers, the LCS relies on powerful water jets. Independence-class vessels use 4 massive jets, while the Freedom-class uses 2 paired with steerable thruster pods. This gives the ship razor-sharp maneuverability. It can pivot, accelerate, or counter rolling waves within seconds. When storm swells try to knock it off course, the ship answers back instantly. Construction materials further enhance this resilience. The Independence-class uses high-strength aluminum alloys chosen for their strength-to-weight ratio and corrosion resistance. While some critics once questioned aluminum's place in warship design, its lightness allows the vessel to move with waves instead of fighting them. The Freedom-class blends steel and composite materials, giving it a structure that flexes slightly under stress, absorbing wave impacts like a shock absorber. Inside, structural reinforcements act like a car's crumple zones, directing stress away from vital systems. This design allows the LCS to maintain full operational capability in sea states that would force other ships to slow down or change course. During Pacific deployments, crews have reported holding course through 20-foot waves without compromising speed, mission systems, or crew safety. High on the superstructure, the bridge stands like a command tower, armored with specialized glass that can endure repeated impacts from spray and wind. Its elevation gives officers a clear 360-degree view, even when swells rise over the bow. From here, every movement of the ship through stormy seas is controlled with precision, guided by a design meant not merely to survive, but to dominate. Beyond its physical form, the LCS is wired with advanced stabilization technology. Thousands of sensors embedded throughout the hull continuously feed data on pitch, roll, wind, and wave patterns to automated control systems. These systems make micro-adjustments in real time, balancing the vessel like a surfer on a giant wave. If a sudden rogue swell hits, the ship responds faster than any human crew could, countering the force to keep the deck stable and systems online. This integration of structural ingenuity and intelligent response is what sets the LCS apart. While other ships might retreat or reduce speed to ride out the storm, the LCS holds its course, ready to launch helicopters, deploy boats, or fire weapons in conditions that would cripple lesser vessels. It's not just a ship, it's a statement. The mission continues, no matter the sea. To understand why the Littoral Combat Ship performs so exceptionally in violent seas, you have to step inside its technological core, a place where engineering precision meets real-time data. Every inch of the LCS is wired to sense, react, and adapt. Its ability to stay mission-ready during brutal weather isn't just luck, it's calculated dominance. At the heart of this capability is the ship's sensor network. Dozens of radar arrays, wave scanners, gyroscopes, and accelerometers continuously monitor the environment. They map wave height, direction, wind speed, and hull movement down to millisecond intervals. This constant stream of data flows into the ship's stabilization computers, which analyze and respond automatically. When the ship pitches unexpectedly, the system adjusts waterjet thrust angles, ballast distribution, and control surfaces simultaneously, bringing the vessel back into balance before the crew even feels the shift. The bridge design reflects this modern philosophy. Instead of separate compartments for steering, navigation, and engineering, The LCS uses integrated control stations. Operators sit at ergonomic aircraft-style consoles equipped with multiple touchscreens. These displays show wave forecasts, structural load diagrams, propulsion output, and mission data all in one view. Helm commands are executed electronically, eliminating the mechanical lag of traditional steering systems. In heavy seas, this instant response is the difference between smooth maneuvering and violent lurches. Below deck, over 7,000 sensors track hull integrity, water intrusion, and compartment pressures. If flooding occurs, automated pumps activate within seconds. Watertight doors seal automatically to prevent progressive flooding, buying the crew valuable time. These systems don't just protect the ship, they protect lives. Environmental monitoring tech keeps an eye on approaching storm systems, giving commanders real-time updates on developing weather patterns hundreds of miles away. This early warning allows them to adjust routes or prepare the crew well before danger arrives. Crew training plays a decisive role too. Sailors undergo simulator training that replicates extreme sea states with frightening accuracy. Using real deployment data, these simulators recreate the sensation of towering waves, sudden rolls, and system failures. Crews practice handling emergencies repeatedly until their reactions become instinctive. By the time they face real storms, they've already been there dozens of times virtually. Its flight deck is another engineering marvel. Both Independence and Freedom variants can launch and recover helicopters in heavy seas that would ground operations on many other ships. The Independence class, with its wider beam, offers exceptional flight stability, while the Freedom class minimizes turbulence through smart hull shaping. This gives the Navy reliable air operations in conditions where flexibility can make the difference between mission success and failure. Operational data from real deployments proves these systems work. In the Pacific, Independence-class vessels maintained full functionality through tropical storms, keeping weapons and sensors online. In the Atlantic, Freedom-class ships faced long, rolling swells, but stayed on mission thanks to their semi-planing hulls and automated control. Commanders consistently reported superior station keeping, allowing them to conduct boarding operations, launch boats, or support other vessels, even as seas rose around them. The LCS doesn't just endure the ocean's fury, it masters it. Through a blend of structural design, automation, and human skill, these ships turn rough weather into just another operational parameter to manage, not a show-stopping event. This adaptability gives the Navy a tactical edge, where other ships might retreat to safer waters. The LCS pushes forward, holding the line when conditions are at their worst. It's proof that modern naval power isn't just about firepower. It's about control, precision, and resilience in the face of nature's most violent forces. Beyond its wave-crushing design and cutting-edge systems, the Littoral Combat Ship's real strength reveals itself during live missions in hostile environments. When other vessels would slow down, alter course, or retreat, the LCS maintains full operational tempo. This isn't theory. It's been tested repeatedly across the Pacific, Caribbean, and Atlantic. During extended operations in the South China Sea, Independence-class ships faced relentless swells generated by tropical systems. While nearby vessels adjusted their routes to avoid the worst weather, the LCS held its station. Its trimaran hull cut cleanly through cross seas from multiple directions, while the integrated water jet propulsion kept the vessel steady and maneuverable. The crew continued surveillance, launched helicopters, and maintained full weapons readiness, proving the platform's capability in conditions that would sideline many warships. In the Atlantic, Freedom-class vessels faced long-period ocean swells, waves that can destabilize ships by causing deep, rolling motions. Their semi-planing hull design allowed them to ride atop these swells, reducing roll and pitch dramatically. Commanders reported exceptional control, even while executing complex maneuvers like launching RHIBs for boarding operations. Where traditional ships might struggle to maintain position for small boat launches in heavy seas, the LCS performed with remarkable precision. This ability to remain mission-ready translates directly into strategic advantages. In rough weather zones where adversaries might assume U.S. naval operations would pause, the LCS keeps patrolling, collecting intelligence, and projecting presence. This unpredictability disrupts enemy planning. Whether monitoring choke points, interdicting traffickers, or supporting carrier groups, its capability to operate where others cannot ensures persistent pressure in critical regions. Weapons performance further underscores this reliability. The stabilized 57mm main gun maintains high accuracy against fast, maneuvering targets even in violent wave conditions. Surface-to-surface missile launchers incorporate motion-compensating fire control, ensuring precision strikes despite the ship's movement. This all-weather combat effectiveness means the LCS isn't just a patrol vessel. It's a combat platform that can engage threats in situations where older ships might be forced to stand down. Aviation operations add another dimension. Both LCS variants can launch and recover helicopters in high sea states, something that's vital for anti-submarine warfare, search and rescue, or rapid response missions. Independence's wide flight deck provides remarkable stability, while Freedom's refined aerodynamics minimize turbulence. This keeps air operations running smoothly when others are grounded, allowing the Navy to maintain aerial overwatch even through storms. Another key factor is crew optimization. The LCS operates with smaller, highly trained teams who specialize in fast reaction under pressure. Fewer personnel mean quicker coordination when responding to sudden changes in weather or mission demands. Automated systems handle much of the heavy stabilization work, allowing human operators to focus on tactical decisions rather than manual control. Extensive redundancy backs up all of this. Power systems are layered to keep stabilization, propulsion, and control operational, even if primary systems fail. Remote-operated valves and automated pumping stations handle flooding threats without exposing sailors to dangerous conditions. Every second counts in heavy seas, and these systems give crews those seconds when they matter most. The end result is a ship that isn't just designed for calm waters near coastlines, but one that thrives in the unpredictable reality of modern naval warfare. Its performance in rough seas proves that technology, design, and disciplined crews can push the boundaries of where the U.S. Navy operates and how effectively it fights, even when nature itself seems to be the enemy. In the end, the Littoral Combat Ship story is one of modern engineering defying nature's oldest challenge, the ocean itself. Where older warships might slow down or change course, the LCS holds its ground, slicing through waves that would sideline other vessels. It's not just a ship. It's a fusion of advanced technology, innovative design, and precise human skill built to dominate both calm waters and storm-tossed seas. The Independence class employs a futuristic trimaran hull, a central structure flanked by two outer hulls, creating a wide beam that resists rolling and enhances stability. The Freedom class uses a semi-planing monohull that rides over waves rather than slamming through them, reducing impact and increasing crew endurance. This dual design approach allows both variants to remain fully functional in wave heights that would force other vessels to reduce speed or retreat. Add to that the powerful water jet propulsion systems, 4 massive jets on Independence and 2 jets plus steerable thrusters on Freedom, and the result is unprecedented maneuverability. Even when monstrous swells try to throw the ship off course, the LCS responds instantly, carving through the sea with precision. Its construction materials also play a crucial role. High-strength aluminum on the Independence class offers a superior strength-to-weight ratio, letting the ship move with the water rather than against it. Freedom's hybrid steel and composite structure flexes under impact, dissipating energy like a shock absorber. Inside, over 7,000 sensors constantly feed data to advanced stabilization systems. These systems predict and react to wave patterns in real time, adjusting thrust, trim, and internal systems to maintain balance and performance. The bridge resembles an aircraft cockpit. Multiple touchscreens, integrated controls, and ergonomic layouts give operators total command. Sophisticated software continuously fuses environmental data with ship motion, ensuring steady navigation even in violent conditions. Unlike traditional vessels with separated control stations, the LCS integrates helm, propulsion, and systems management into one unified hub, drastically improving reaction time when conditions shift without warning. What truly sets the LCS apart is how its wave-handling technology translates into operational dominance. These ships can patrol littoral zones during storms, maintain radar coverage, launch boarding teams, or conduct helicopter operations when others are forced back to port. Their presence extends U.S. naval reach, ensuring missions like maritime security, intelligence gathering, and rapid response continue uninterrupted. This capability is not theoretical. Deployments in the Pacific and South China Sea have proven it repeatedly. Perhaps the greatest legacy of the LCS lies in its influence on future naval platforms. The technologies perfected here, from automated stabilization to integrated control systems, are being studied for next-generation destroyers, frigates, and unmanned surface vessels. In an age of intensifying storms and contested waters, being able to fight the sea itself is as crucial as defeating any enemy fleet. The Littoral Combat Ship is proof that naval power isn't only about weapons. It's about endurance, adaptability, and precision under pressure. When the waves rise, the LCS doesn't yield, it fights on.